Oh, yo, what's up, everybody? Welcome back. Today, we are writing a Wayland client from scratch to try to figure out how Linux opens Windows. The idea here is that we are part of this kick where we are trying to understand kind of like the graphics stack on Linux top to bottom, with the hopes that if we were to understand this thing fully, we would be able to make our own graphics card and have like an API that is sane someday in the future, right? So kind of like the end goal of this overall project is it would be nice to be able to write some sort of program that hooks up to a virtual machine and 3D accelerates some 3D render inside the machine, right? That's kind of the goal. And today we are tackling, I guess we there are a lot of angles to tackle this problem from. We kind of have like a very basic knowledge of what happens when you do 3D, right? We have this window open right here, which is this like 3D render of like a monitor, and so there's some stuff on it, and there's like shadows and lighting and stuff, right? Really basic. But this is kind of like at the level of like OpenGL and above, right? We've done some 3D work with OpenGL, but we don't really understand what happens underneath that, right? And so like this, for example, there's just some window library that we called out. I think this is using Rust's Winit, and he kind of does all that stuff for us. And we know that we like when we work with like GLFW or Winit or like these like windowing libraries, you like get a window and then you ask to get an OpenGL context from that window. But it's like, what does that mean? What does it mean? We don't know. And so the hope is that if we were to implement our own Wayland client, that will demystify some part of this whole thing, and hopefully we will chip away at some of the lack of knowledge that we have. We've been reading a little bit about this concept called DMA buff, which is like a way for you to transfer GPU objects between processes. And I believe that under the hood, when you do some sort of like OpenGL drawing in Linux, you have something that's like you have like your monitor, right? We'll draw your little monitor, and he's maybe got like a little green light here because he's on, right? The monitor's on, and in here you have like your like taskbar, right? Like I've got like my little programs down here, and in this thing there's like maybe like a program with an X with like something drawn inside, right? What is happening here is that like this whole screen is like some OpenGL renderer, right? Probably, right? You could do it with Vulkan, you could do it with software, whatever. But likely like Kwin, which I'm running right now, is like this like OpenGL renderer. And I believe what's happening is under the hood, we we render to like an OpenGL texture essentially here, and we like transfer that texture to the parent process Kwin. Well, parent is wrong. To the process of the compositor, and we export that texture as like a file descriptor that he knows how to import. That's kind of my understanding of this. And so what I'm hoping to gain from this is like, one, how does like a program get some sort of graphics handle, and two, how can we share graphics handles between processes? And I'm hoping that by going through that, we will encounter some form of low-level APIs that are used to do these like transfer between processes, and we can check if we were to implement a GPU driver at some point, what would we have to implement in order for that to work? That's kind of what I'm hoping to gain from this. So the plan of action today is not to do any of that OpenGL stuff, but mostly just kind of get the base of like, what the hell is a window, right? Like when I get this thing, what is it? I don't know. And so I think the plan of action is approximately, let's like communicate with the Wayland server, get a window, draw something in the window, and then like maybe handle some inputs in some way, get some like key presses or something, just to like understand what is going on. When I talk about Wayland, so the backing knowledge that we have right now is that Kwin, this like process that draws all of our windows, we know that he's acting as like a Wayland compositor. He also can act as an X11 windowing system, and we are just going to ignore that part of the problem because the more reading I do, the more I actually think that Wayland seems kind of cool and X seems old. So we're gonna focus on one problem right now, and yeah, let's just jump in. So I also have read a little bit of this. I skimmed this article the other day, learn Wayland by writing a GUI from scratch. And he kind of talks about Wayland basics. He kind of talks about this concept where in order to open a window in Wayland, you basically communicate with this like kwin process, the Wayland compositor process, whatever that may be. In our case, it's going to be kwin. You communicate with him over some Unix socket. You send some messages to him, and in the basic case, the only like core protocol thing that Wayland supports is using a shared memory file as like a backing pixel storage, essentially. So we will try to set up this shared memory thing, send it over to the compositor. Hopefully he'll draw it, but we'll see. So that's why we're talking about a Wayland server at all. And so I think step one is just talk to the Wayland server at all. Okay. So another resource I've been reading is this Wayland book. This thing is pretty sick. And then I also wanted to look at this Wayland app. Wayland app /protocols. So my understanding here is very limited, but from this blog post, it seems like there's some sort of binary representation of a Wayland object. They call it in the Wayland book wire protocol, right? So here is kind of like what we will be sending over there. Could you put that Wayland from scratch thing in the chat? Yeah, I did a little earlier, but I'll throw it over there again. So there is this concept of a request that has, I think, where did I see the kind of definition of this thing? Here. So you have the ID of a resource that we want to call a method on, the opcode of the method, the size of the method, and then after that, it's just kind of like, you know, whatever you want, whatever the protocol item says that you can do. And apparently the first thing that you're supposed to call is this get registry command. So I think what we are going to try to start with is we are going to try to start with opening a connection to our Wayland display. And then we will try to call this get registry command. And we are going to have to figure out how to serialize these things. According to this blog post, libwayland kind of abstracts this stuff for us usually, and I believe that there is this like protocol definition file, which is what I was looking at here, where this protocol definition is backed by this like XML blob. Let's see if this will open it. And this XML blob defines all of the interfaces. Fuck, I didn't want to click blame. I want to click raw. Is there a like download, open raw? Here we go. This is like some XML file that defines all of the interfaces, as well as their arguments. So we will probably be looking at this a little bit as well, but maybe we will browse it through this protocol browser. Okay, step one though. Step one is to, make an application and try to connect to the Wayland socket. So let us do our typical Zig app. So we'll do edit source main Zig, and in here we will do pub function main. He returns void, and we are going to use the standard library of Zig because I'm not crazy. Okay, we're allowed some dependencies, just very limited. Standard library and standard library alone. In here, what are we going to do? We are going to try to connect to the Wayland socket. So if we look at our environment, we have this Wayland display thing. And I believe I was reading that if you go to your XDG runtime dir, here, if I go to run user 1001 Wayland 0, this is a Unix socket that we can connect to. I don't think it tells us this, but I'm pretty sure it is. Can we do run file on that? Is that allowed? Socket. Yeah, so this is a Unix socket that we can connect to. So how do we do that? Stood POSIX open, probably. And we will open, I guess we will start with getting the environment. So we'll start with XDG runtime dir is going to be stood process env get env map, sure. Do we want to call get env map, or do we just, is there a way to like just get environments? Get env w get env var owned. Is there like non-allocating versions of this? If we are Linux, is POSIX get env. That's what I'm looking for. That's what I'm looking for. So here we are looking for xdg runtime dir, and this thing can return a null if it does not exist. So we'll say or else return error no xdg runtime. Okay, and then we are also looking for I forgot wayland display. Wayland display is wayland display. And this is error or else no wayland display. There's supposed to be some sort of fallback mechanism that you're supposed to do here, but we're going to ignore that for now because we are not trying to make a generically successful wayland client. We are trying to make one that will explain to us how things work, right? We're making a shitty version of things and ignoring the important parts. I'm actually going to put main over here, and I'm going to make this its own function, and I'm going to just call this like open wayland connection is what we'll return here. I don't know what we'll return here yet, but we'll figure that out. And then here we'll try, we'll call this function in a minute. Okay, so here we are going to join these things together. So does this thing end with a slash? No, it does not. So probably like std fs path join feels kind of nice here. So here we will be like, we are going to join together xdg runtime dir and wayland display. And then here we will say, this is probably tryable. Yep, this can fail. And here we'll say wayland display socket path is this. Okay, and then we will defer alloc free socket path. Here, I guess we need an allocator. I think that's reasonable. Okay, so we'll pull this in as an import. Boom, boom, boom. And then here, I guess we have to make an allocator. So we will use the general purpose allocator from std heap general purpose allocator. We don't give a fuck about the options. We just need one, and we'll do a little GPA DNN over here. And now we call open wayland connection with alloc. Boom. We do need the generic interface of this thing, though, so we will call GPA allocator to extract the interface from the general purpose allocator. Nice. Nice, nice, nice. Okay, next steps. Next steps. We are going to do something like open the pocket. We just have to open the socket. Yeah, so we're just gonna do like, I don't know if there's like a special call to do like open Unix socket. Open, sorry, it's because I don't think you're just supposed to call open. I do not think that is the case. I think you're supposed to do your typical like connect, which this guy probably has an example of, to be honest. We probably should have skimmed this a little better. So he calls, yeah, he calls socket AF Unix. This sounds familiar. And he calls connect with the address, where the address is probably from this wayland display. He gets this and he puts it into sun path plus socket path len wayland display len. Okay, so we can probably assume that the Zig standard library has some way to do this, right? So we need to like create a socket. So we call connect. Presumably we call socket first, right? So std POSIX socket. Domain is going to be std POSIX system AF Unix. Okay, right? So man to socket. Domain, type, and protocol. So type is probably dgram or probably dgram, right? That's what this sock stream is what he does. Sequence reliable. Oh, because I guess the Unix socket is reliable even though it does not have like a bunch of negotiation stuff. Sure. So what was it again? It was sock stream. Okay. And then what was the third argument again? Third argument is protocol. So is that not domain? Is that not domain? What does this guy do? He just writes 0. Okay. All right. Okay. So then we get a socket, and then here we can connect to the socket with, presumably he is going to give us the sock adder and socklen. Right. Okay. So man to connect. Here we take the sock adder and socklen, and sock adder, probably we were supposed to allocate one of these like Unix socket things. If I remember correctly, there's kind of like this like common sock adder struct that there's like a sock adder struct who gets embedded in a sock adder Unix struct. If I think. So we should be able to do like std POSIX system sock adder. Let's just kind of see what we have available to us. Nice. Okay, so it looks like we have like kind of like an arbitrary data thing, and it looks like they have a pubconst un thing and a path argument. Nice. So we can just call sockadder.un, and that will give us the structure that we're actually trying to use. Like this. So adder is this, like boom, 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 and then we will specify path is equal to I guess we just say path is equal to socket path. And does this thing, is this a slice in this? Oh, it is. I guess we wanted to join Z to get this thing 0 terminated. And then that means that we can, I think that this won't work. I think we have to do like, this is a variable thing, and we will mem copy it in, right? So it'll be like mem copy adder from 0 to socket path len. Sorry, adder dot path. We're going to copy that in from socket path. Boom. And here I guess we have to assert that adder path len is less than or equal to socket path len, or else we will fucking crashy. I guess arguably this assert is kind of useless because this will assert for us, but you know, I guess it kind of makes more sense to do if this return error path too long. Boom. Sure. And then to connect now, we just pass in adder as a pointer, and then size of adder as our length. Should be good. And then I guess we return this, right? So this guy just returns void. So I guess we return the connection now. So return socket like this. Which means that here we are not going to return void. We're going to return a std os POSIX socket t like this. And then here we're going to be like const socket is this, and we will kind of just leave it here for a second and try to see if that's good enough. Pub function build. Let's make our little build command. So he's gonna import std. Okay, and then we're gonna be like b add executable. He is going to be named wayland client from root source file is b path source main zig, boom, and target is equal to target, and optimize is equal to optimize. And then we'd have to find const target is equal to b standard target options. And optimize is standard optimize option. Okay, and I assume these guys have like things they pass in. Yep. And then we do this. It makes us an executable that we install. And that should be good enough. Should be good enough. Missing struct field path. Let's see. Let's see. First of all, maybe this. Uh, hmm. Can I copy arrays in Zig without this? Or can I do like a path is equal to like, I guess here you would do something like this. You do like, is this how you're supposed to do this? Times 104? Like, can I just do this? Is that legal? Yeah, right. That doesn't, he doesn't like that. So how do I initialize an array? Am I stupid? Zig initialize array. Oh, I guess we could just set it to undefined. Then we can pass it in. That feels fine to me. That feels fine. I'm sure there might be a way to do it directly that I just don't know of, but we will ignore that for now. Okay. He is mad because const sockaddr is not sockaddr un. So does this guy provide some sort of like nice little casting functions for us, or do we just have to do it ourselves? Let us see. I think we probably have to do the pointer cast ourselves. Doesn't really look like there's a nice little casting function. So can we just do pointer cast here? Is he gonna be mad because the pointers are not like the same? Size of type of adder. It's probably more like what we're supposed to do there. Okay, there we go. And he doesn't crash, which is pretty good for us. That's a big win. Now the question is how do we determine if this is correct? We're going to have to send some message, which it looks like is this get registry command. So maybe the Wayland book will tell us what each of these types are, right? So the wire protocol is a stream of 32-bit values encoded with the host byte order. These values represent the following primitives. I think that stream of 32-bit values doesn't feel right because some of these things are not 32 bits, unless we have to pad to 32 bits no matter what. Oh, I guess 32, 32, 8-bit signed. Whoa. What does this mean? 24 8-bit signed fixed point numbers. Okay. Int are 32-bit integers. New ID string array. Okay. So the wire protocol is a stream of messages built with these primitives. Each message is an event, in the case of server to client, or request from client to server, which acts upon an object. The message header is 2 words. The first word is the affected object ID. The second is 2 16-bit values. The upper 16 bits are the size of the message, and the lower 16 bits are the event or request opcode. So if I understand correctly, I don't know if like endianness is defined here. I don't know. Can we ask the idiot? In the Wayland protocol, is endianness defined or based off host system? Instead, it generally relies on the host system's NES. I mean, who knows? Who knows what if this guy's right? Doesn't it say hose order in the book? Host byte order. Yeah, sorry, it does say that. It does say that. I just can't fucking read. Okay? And you guys have to stop making fun of me for it. Okay, so in that case, when they're talking about the 16-bit, the upper and lower 16 bits, they're kind of saying like we don't know which set of bits comes first. We just know that within this 32-byte value, we have to shift stuff up into the upper or lower bits. I'm pretty sure is what it's saying. So we can make our header. This is always going to be the object ID, and then this is where I get a little confused. I guess we're going to call this like one 32-bit value. We could do it as we could do like header little endian, and then we can just kind of put stuff in as we feel. Maybe that feels nicer to me. And in that case, if we are little endian, then the lowest byte value, the least significant comes first, which means that the lower 16 bits comes first. So we should have the upper 16 bits is the size, and the lower 16 bits are the opcode. And then we will make this a packed struct. Okay, so that these things are certain to line up. You could do it as a union between 32-bit uint and two 16-bit uints, maybe. I think that you'd have the same problem though, right? Where the order of the fields depends on the endianness. I think. So you would have to call them A and B and then assign A and B in different orders. The message arguments follow based on message signature agreed upon in advance by both parties. To understand the matches, the client and service have to establish the object in the first place. Object ID 1 is pre-allocated as the wayland display singleton and can be used to bootstrap other arguments. We'll discuss this in chapter 4. Okay, so presumably, when they talk about creating a display, maybe we'll look at this guy. He kind of talks about like get registry. So if we look at the get registry command, this is run on wayland display with an argument new ID WL registry. So new ID is probably defined here as a 32-bit object ID, which allocates that object when received. Maybe I'm thinking in C, but you could, if def based on indexes, set the order of the two 16-bit parts. Yeah, you could. You could do something similar in Zig. In Zig, you can do like sorry, let me think for a second. I think you can do like const built in. You can do something that's like comp time. You can do like const header is equal to comp time if built in CPU, maybe endian arch, maybe endian is equal to little. You can do header LE else header BE or something like this, right? You could do this, or you could do this in like other, you could assign based off that or whatever. But I'm just not gonna think about it because we don't have to. We are always gonna be on a little endian system. Okay. Maybe that's fine. It's fine. Now we can make a get registry. And I guess this will return something, but we don't really know what yet. I guess he will have to take in the socket that we're sending on. I guess. Joel. LCQ, thanks for the raid. What is up, you guys? What is up? So I don't know if Joel's that spinning fish, right? And I'm not seeing a spinning fish. Am I supposed to have some sort of extension installed on Twitch to see the spinning fish? But either way, I appreciate even though I can't see it, I can imagine it. And I can imagine the spinning fish great. And I appreciate you guys for sending it. So what's up, you guys? We are working right now on making a Wayland client with no dependencies. So we are kind of following a little bit of this guide, Wayland from scratch. as well as we've been reading this like Wayland book. We're trying not to reference, we're not trying to like copy paste out of this. We're just trying to use them as like a little bit of a guide of where we're supposed to go. And what we have read so far is, well, what we have right now is we have like a connection to a Wayland socket. And we are going to try to execute a get registry command on it. So let's see how we do that. So they say we have a registry, which is a new ID. And does it say the opcode of this thing? Where does the opcode come from? We have the raw protocol open here, and we're looking for get registry. So I'm confused a little bit about where this opcode is supposed to come from. A little bit confused. Let's look at what this guy did for that. So he called get registry, where he wrote the display object ID and then the get registry opcode. So where is he getting this from? He just has that written as 1, but like, you know, where does it come from? Where does it come from? Right, I would assume that it has to be in this protocol somewhere. I wonder if it's just like something crazy, like the index into the interface. That would kind of suck. But the opcodes start from 0 and increment based on the order in the XML. Yeah, okay. That doesn't, I mean, that lines up. This is 1, and we can double check that like Wayland display sync is 0. Oh, he never calls a display sync? But yeah, we can probably assume that. I think that way the way it works in Wayland Scanner is Wayland Scanner reads in the XML in order and generates those IDs based on the order. They're specified in the XML, so the first thing gets ID 1, next gets 2. I think that you're almost there, except that I am seeing 2 things. I'm seeing sync come before get registry, and I'm seeing get registry at 1. So I think they're probably 0 indexed. I think. So we will assume that for now, and we will come back later if we need to. So opcode is equal 1, I guess, or maybe we'll just say const header is a header little Indian with the ID is, we saw somewhere that the object ID for the Wayland display is fixed at 1. I think we saw that. Was that in here? Maybe it was here? And it also might have been here. Here. I swear we saw that it was fixed at 1 somewhere, but I don't remember where. Display. Here. Object ID 1 is pre-allocated as Wayland display. So here, I guess we'll say const Wayland display object ID is equal to 1. And maybe we can do something like object IDs. Maybe we do it like this. And then we say object IDs display like this. The opcode was going to be 1. And maybe we put these somewhere too. So we'll say like display ops for now. We might turn this into something that we parse later, but for now we will just write this is get registry. Okay, so this is going to be display ops get registry, and we are going to pass in as well a size, which should be where did they say what size was? It must have just been size of the message including the header. So this is going to be 32 bytes. So sorry, 32 bits, so 4 bytes plus size of header LE. We could also do it another way where we have we create a new structure that's like the get registry message. Oh yeah, this feels like it's gonna be nice. And he's gonna have like a header, and within him he's going to have the new ID, right? And so then then we can construct this kind of like this way. So const message is a get registry message. This stuff is all header. But the size here now gets from size of get registry message. Boom. Boom. Okay, and then the new ID is going to have to be passed in, probably, because this is going to be from some sort of like ID allocator. Probably. And what's he mad about? Expected expression found equals. Am I? Oh, because this needs equals here. And then, what is it actually? I'm actually confused. Expected statement found, comma. I don't know if I've just been writing the wrong language for long enough that I'm lost. This feels right to me. Certainly it's not. Okay, expected. Dude, am I mental? For the request, I think the size should be size of header LE. The reply is header plus new ID. Let's look again. Protocol says no. The argument, he has an argument here. He's an argument. I'm pretty sure that's right. Guys, am I mental? Why? Why can't I instantiate a struct? Oh, because I forgot. No, I'm actually confused. Missing leading dot? Where? Here? No. Guys, I'm high. Oh, here. Thank you. Thank you, thank you, thank you, thank you, thank you. Okay. Client allocates the IDs, might be weird, but it sounds weird, might be right. Yeah, because I think it's completely asynchronous, so... I don't know, we'll see, we'll see. Okay, so I think I was reading in this learn wayland thing that they they just kind of like allocate increment the number each time we want to create a new resource. So in wayland, to create an object, we simply send the right message followed by an ID of our own. IDs should be unique to, so we simply create a number, increment a number each time we want to create a new resource. Seems good to me. So maybe we put all of this in a structure that's like a wayland connection. Maybe we will regret this later, but for now, yeah, maybe we'll do wayland ID allocator, right? And here we'll just be like ID is 1, 0. Well, there's already an ID of the display at 1, so we should probably start this at 2, and then we'll just be like allocate, and he will return. I guess this is going to be a, sorry, u32 is equal to 2, and then we are going to take in self as a wayland allocator, and we will return a u32, and we're just going to be like defer self.id plus equals 1 and return self.id. Boom. Which means that we will be able to easily get registry with the new thing. And okay. So then we just have to send the message. So we'll be like self socket, nope, stood POSIX write to the socket, and we will write the bytes. So just stood mem as bytes message. Seems reasonable to me. So let's do a get registry, and with our ID allocate, boom. Okay, and then we will say var ID is equal to wayland ID allocator. I think we're chilling. Any reason you're using packed struct instead of extern? Not sure, but packs might get padded out to the powers of 2, like exotic ints. I just thought not particularly. I just thought that the packed structures would keep the ordering and like I thought I could predict the packed structures better. I could be wrong there, but I thought I could. Because like if I do extern struct u32 u16 u16, like if I start getting like more creative packings in here, I don't really know if it's going, like if this was a u8 here, like if I wanted like u8 u24 instead of u16 u16, I feel like I would be able to predict this better. You know? All right. We don't compile here because we forgot to write try on this write. And type of view size ignored. So here we will, I guess we will say const written is equal to this, and assert that written is equal to message size of type of message. Or I guess it makes more sense to write a size of get registry message. All right. So no errors, which is good. And so now we should probably, presumably, read from the socket, right? Presumably. To get the response. So can we do while? Let's just get like a buff. We'll start with a big buff. Var buff is equal to 1024 U8s. There we go. And we'll just start by doing a std POSIX read into this socket with buffer. And we'll say response is equal to this thing. And can we like just do like this needs to be tried? And does this give me a length response len, which means that we have like response is equal to buff from 0 to response len. And then let's just maybe, I don't know, I guess we print the response. Okay, so this is going to be, and can I like format a slice with like, how do you do this? Percent, you do like, if I want to do hex formatting with 2 leading zeros, there's like some format thing that we can call. It's X, and then you specify colon width fill. So specifier argument above each thing. So argument specifier colon fill alignment width. Right. So I want 0 left arrow 2 is what I want. And I guess we'll print a 0. Will be like this, and then we will print the response. I think that's how we do this. I think this is allowed. We will see. Okay, so we do get a response back. And if we were to try to format this nicely, we would see 1, 2, 3, 4. So we're getting response message 20, assuming this is the same, which it might not be. We're seeing, yeah, I guess we should double check what the event format is. Wire protocol is a stream of messages built with these primitives. Every message is an event or request. The message header is 2 words. Okay, yeah, so the message we get back should have something that is this ID, which looks like ID 20, right? That is very long, 240000. So that's a big ass number. So oh no, wait, sorry, because there's broken up in 16 bits. So first two bytes of this are the object ID, and the second 2 values are the size. Right. So we get message 20, object ID 0, size 24 in hex. That seems pretty reasonable. So maybe we start just by trying to process these messages. Right? So read response, handle response, parse response. How do I want it? Response iterator. That feels like what I want, right? So here we're going to have our buffer. And we are going to have some sort of function What's object ID 0? I don't know yet. We'll find out. You call the method on 1 and 1 to allocate 2. It could just be that it's like a null response, right? It could be. We will find out in a second. And we will say that he just returns maybe something that's like, he's going to have a header, right? As well as data. Okay. And here we're going to return an output. And we're going to be like, header is equal to buff from 0 to header size of header. Boom, 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 right? Fuck. Can we do this as header bytes? And then can we do const header is stood mem bytes as value as a header LE from header bytes. Okay. And then the data is like, I guess we'll say header size here so we can stash this shit and use it without having to type at every time. Here we can go const data is equal to self buff from header size to header dot something size. Yeah, and then we return header. Actually, we don't even need to return the header. Oh, we do because we need the opcode. And then on each of these accesses, we have to do some like bounds checking, right? So here we have to do if self buff len is equal to 0. We're chilling. I guess we'll do if self buff len is less than header size. We return null, right? So maybe we got like half a message, right? And if we got half a message, then like maybe we're just not ready yet, which is fine. And I think we do the same thing here. If self buff is less than header size, right? We do the same thing. Nothing to do. But if it is, then we're chilling. And so then here we will defer. I guess we don't even have to defer. Self buff is equal to self buff from header size onwards. And here we have to be a little careful because this is not valid if header size is equal to the buff length. So if self buff len is equal to header size, we do self buff is equal to nothing. But otherwise we consume it. And that feels like a named thing. Consume len. Right? Just, you know, we can get a little crazy. We can name our functions. Wow, look at us go. Header size. Boom. Boom. All right. So now we should be able to kind of iterate over this thing and just kind of print out information about it, right? So we should be able to be like, var it is equal to response iterator off of response. That's not how you do this in this language. It would be like this. While we get some stuff, we'll call this event. I guess calling this response IT is wrong. These are called events in this language. Or not this language, this protocol. Okay. And while we have some event, we can print it. Don't you have to consume the header bytes? The header is the size of the data is part, or the header size includes the size of the header. Here they say including the header itself. So we only have to do one consume. Only one consume. All right. So he's mad because I said I have to try. I think there's actually no failure cases in here right now, so we can get away with just no failure. Found a line 1. That's interesting. Yeah, that's a good point. That's a good point. So I guess we have to copy it out. Expected this. Oh, here we just have to dereference, which might not be illegal if the alignment is wrong, but it looks like Zig allows it, so we're probably fine. Okay, so we got a lot of op zeros, ID2, with different lengths. So part of this feels good because there is consistency. Part of it feels bad because why the fuck are the sizes of our messages all wrong, right? But maybe this is like an interface thing, and maybe the following data will contain some more information for us. It would also be interesting. So first of all, let's check the response line here. So we got this many bytes. Right, because this is interesting in some way, shape, or form, right? If we maxed out our buffer, then we got a problem. So we did max out our buffers. That's weird, right? Do we max it out even when we increase the size? No. Okay, so there's just a lot of stuff up front. And what happens if we don't call get registry before doing this? Right? Like, nothing. Okay, so this looks like the get registry command is returning us a whole bunch of shit all at once, right? That's kind of what it looks like. That is what it looks like. Here, so yeah, let's just figure out what the events are. So presumably, this get registry object allows the client to list and bind global objects available from the compositor. It should be noted that the server-side resources consumed in response to get registry requests can only be released when the client disconnects, not when the client-side proxy is destroyed. Therefore, clients should invoke get registry as infrequently as possible to avoid wasting memory. Oh, that's enumerating all the objects the compositor supports. That sounds likely. So now the question is what comes back, right? So yeah, this doesn't really seem to oh, WL registry? Is that we called get registry, right? So the singleton global registry object, the server has a number of global objects that are available to all clients. These objects typically represent an actual object in the server. When a client creates a registry object, the registry object will emit a global event for each global currently in the registry. Globals come and go as a result of the device or monitor hot plugs. Okay, so if we look at we're seeing ID2, which is the ID we created, right? Right, we created ID2. So if we specify ID3 here instead of 2, we should get all of these responses should come back with a 3 on them. No. Okay. That's interesting. What if we specify ID1? This is very interesting. So everything except for ID2. Okay, that's weird. That's interesting. That's an error event. Look at wdisplay error. But if we are specifying a new ID, I'm surprised that we aren't allowed to specify whatever we want, you know? Yeah, that's surprising. I guess maybe maybe this one is a specific thing. But we could look at the error event, because the error event, I think, is probably one that we want to process first. It might expect them to be in order. That wouldn't surprise me that much, but it would surprise me a little bit. So here, error. So can we look at, maybe we'll look at this guy, and we will see how he responds to stuff. So we send our first message. So he sends get registry, and then somewhere I assume that he processes wayland handle message. Get registry. Thanks for the C function get registry. The compositor responds with a series of events listing the global objects. Each event contains the interface name, which is a string. Now in the wayland okay. How am I supposed to know that? Does that say here? Can only be released when the client disconnects. Yeah, it doesn't really say what it returns, which just seems kind of shit, right? Globals come and go as response to reconfigure, blah, blah, blah. And the registry will send out global and global remove events to keep client up to date. A client can bind to the object. Yeah, I don't understand how I'm supposed to know that. Look at the global event on WL registry. Ah! Notify the client of global objects. I see. So we can probably assume that opcodes and the opcodes for events and requests are going to be indexed individually. It sounds like. So WL registry is what we're looking for here. So he has bind, global remove. Okay, and then we also have the error callback of the WSWI get registry. So, okay, hold on. So here, if we specify ID2, if we specify ID2, we get back ID2's op0, right? Which we can assume is the global event handle. Now, if we do this again with ID3, we get back ID1, right? ID1 op0. And so I guess here, this is the first event error. That sounds likely to me, right? That sounds very likely. So maybe we try to parse this error event first. Yeah, that seems reasonable. So he has an arg name object ID, which is of type object, arg name code type uint, and arg type message. Okay, so we can probably, eventually it would be nice to auto-generate this, but for now, let's just kind of see if we can figure this out ourselves. So I guess this is going to be in display events. That kind of feels like where this should go, and we're gonna have a how do we want to structure this? I guess maybe this just gets the index here. So this is the event 0. Error we'll call it, because we can't use error. It's not allowed. And then here we will have a function that's like handle display error. Okay. And this is going to have like the data. Yeah. And then we will, I guess, try to process this thing. So we have the display const content. I don't know, doesn't really matter. Here we'll have the object ID, code, and message. Now, how are messages encoded in the wire protocol or strings? String prefix with a 32-bit integer specifying its length, followed by the string context and a null terminator. Padded to 32 bits with undefined data. The encoding is not specified. Okay. Okay. So I guess we will just say that this is the message len here. I guess this kind of indicates that kind of generally strings are going to be variable length, right? So having this thing as like a constant struct that we just cast in doesn't feel quite correct. Really more what it feels like we're going to end up doing on these responses as we iterate these things is we're going to have like a event. So this is an iterator of events. Here we're gonna have more like packet parser is kind of how I'm feeling, right? Right. And in this packet parser, we're gonna have methods to get things, right? So we're gonna have like get string. And I think we'll do the same thing where we have buff as const8, and this thing will get reassigned as we go. And so here we're going to be like, if buff len is less than 4, we have a problem. So we'll return error invalid length, right? Then we will try to get the length. So const len is self buff 0 to 4 as a u32. So stood mem bytes as value u32 this, right? Then we go message is, or s for string, is going to be self buff 4 to 4 plus len, right? So 32-bit integer followed by the string contents and a null terminator padded to 32 bits with undefined data. So we're going to say that the actual len is going to be len rounded up. So how do you do this again? You do like len over 4 plus 1 times 4. Right? This is right. So if you have like 3, this becomes 0 plus 1. 1 times 4 is 4. And this is 4. If this is 4, this doesn't work. Because if you are at 4, length of 4, this is going to get rounded up to 8. So that's a problem. So this is more like len %4 probably gets used in here as like the, yeah, it's just len plus 4 minus len %4. Right? So let's try this again. So you have like 3. You have the same fucking problem. You have the same fucking problem. 4 minus. This should be easy. This should be easy. So we have len. Dude, I feel so dumb. Do you do like a -1 in here to like kind of shore yourself up? Round up to number to multiple. Math seal. This is usually for a single value, right? Okay, what if we did len -1, len -1, this doesn't make sense either. Dude, I should be able to do this. I should be able to do this, and it's frustrating to me that it's not just in my head. Len over 4 times 4, maybe? That's what I was initially doing. Oh, maybe. So this does, if we have 4, This will give us 1. Or, sorry, 4 gives us 4, because this turns into 1. 3 gives us 0. Right, so here, then we have to we have to add 1 if it's... We have to round up if len %4 equals 0. This feels stupid. I was trying to avoid doing it this way, but maybe this is... There's probably some sort of mathematical way to trick this into working correctly. But if we just do this, we can do const rem is equal to len over 4. Dude, shut the fuck up. Else, we do... So if we have 1 over 4, we get 1. So 4 minus rem. Len minus 1 over 4 plus 1 over times 4. I almost got there, but I felt like that wasn't right. But that does... So, yeah. So I feel like I was so close. Because I said, don't I need to throw a minus 1 in there? But then when I started doing this felt wrong. But we can throw it in. So if we have 4, this becomes 3 over 4 plus 1 is 1 times 4. If we have 4, this becomes 3 over 4 plus 1, 4. If we have 5, we get 4. Yeah. That does seem right. That does seem right. Thank you. Mul is a any type, and val is an any type, and then we do mul is type of val, and we turn type of val, right? And then we do mul val. Okay, that's what I was looking for. Round up land 4. Boom. All right. Zig has mem align forward. Zig standard lib. Align forward. S align forward. Align forward. Return address up to the next or current align address. The statement alignment must be a power of 2. Yeah, I'll just do it this way. It's fine. It's fine. So why was I doing this again? Because I wanted to know. Right, so this goes like this. And then this is like how much we consume. Right, so this thing has specifying its length in bytes followed by the string contents and null terminator pad to 32 bits. So I'm assuming that the length is the length of the string. So we would probably chill to do this still. I don't know if this is going to have the null terminator on it or not. We will find out. And then we will consume actual len. So we'll call this consume. And this is going to be 4 plus this, right? Because we have the first 4 bytes and then the actually rounded up length. And so maybe we call it this. So this is going to be the length field plus 32-bit aligned string length. All right, and then we were kind of say self buff dot is equal to self buff consume. We have the same problem, so we want the same consume function that we had over here. So it's going to be packet parser. Okay, and then we'll say consume len, we'll call this, and then we will call self consume len, boom, and return s. Jesus. Okay. Let's call get u32. So this thing has to return a const u8 here. Length check. Yeah, good point. So here, if we have if consume len is greater than self buff len, we have a problem. Yeah. Otherwise, I think we're good. Return const ret is self buff from 0 to 4 as a u32. Val. Return val. Boom. Shouldn't that be above before we're in for the buffer? Yeah. I think so. I think you're right. I think you're right. You might have to handle a case where your read on the socket steps in the middle of a message, right? I think that that is handled in the event iterator. So we should only, on the packet parser, we should only be getting full packet. I guess like calling this packet is maybe bad. But I don't know what else to call it. Event data parser? That feels better, yeah. So we only get full events, so the data should be fully fledged, like fully there, if that makes sense. So now we can do an event data parser with buff equals data, right? And then we can do it get u32 for object. And then we have the code is again a u32. And then the message is a string. And all of these things need to be tried. Boom, boom, boom. And then we can return some output. So maybe this isn't a function. Maybe this is a display error. And maybe this is like a structure, right? That has these things. So maybe it's like kind of like this is like this. This is init, right? And then we just have these fields. So boom, boom, boom. Object ID is a u32. Code is a u32, and message is a const u8, right? That feels pretty good, right? That doesn't feel crazy. Right? Boom, 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 boom. That feels pretty good. That feels pretty good. So now, when we are iterating these events, we can check if it is an event that we know about, right? So we have display events here. We need to get like an object ID mapping somewhere, right? So here we know this like ID allocator actually has to be a little bit more crazy than this. Because he has to keep track of all of the objects. So maybe that gets his own type though, right? So he's gonna have like a map of something to something. We'll have to figure this out, right? So we're gonna have like we're gonna get a number and we're gonna have to map that to like somehow get mapped back to this display error type, right? And I don't really know how to do that yet. So as we iterate events, we're gonna be like switch event dot header ID, right? This is gonna tell us which interface we're working on. Is that correct? Or which object we're working on? I forget. So object ID, the affected object ID. And so I guess our object IDs have like implicit types, right? So we could have maybe multiple WL registries. But this WL registry has object ID 1. So I guess we are going to have like the lookup is going to have to be like ID to type. And then depending on which type, we process the events differently. Yes. Yes, yes, yes. So maybe we'll start with just a function that's like handle WL display has multiple things that can come off it, right? So this is going to have a function that's like handle display event. Right? Something like this. Maybe he will get an event iterator output. And we'll call this event. Okay. Okay, that's feeling pretty good. Then here, create a window. I end up leaving it to SDL. I don't think you really get what we're doing here. The point is not that we want a window. The point is that we want to understand how to get a window. Those are very different concepts. We are trying to understand what is happening under the hood. Okay. So here we are going to switch on the event.opcode, I guess. Right? And we know that our options are error and delete ID. So 0 is going to say, let's start with just like a std log warn unimplemented get header or unimplemented handler for display error. Yeah, that feels right, right? And then 1 is going to be for delete ID. Okay. And then we actually do have an implementation here. And then we'll say else std log warn unknown WL display event D. That feels right to me, right? Right? And then in here, we had the display error type. So here, I guess we just log? Probably? So here we're gonna like get the thing. So is equal to this. And if this fails, I guess we should display Y. So can we do like a std log error failed to parse display error message? And then how do you do like the error backtrace? It's like a error. If the binary is built with error return tracing. Can we just write try here instead for now? I don't really want to do this. We should do this. We should do this. No, we'll just, yeah, we will. I don't know. We'll just write try here. Then I don't have to think about it. And here we'll say std log error, WL display error. And we will print out. What does he get? Object ID, code, and message. So D object this, code this, message this. Okay, it's going together. You know, slowly. Slowly, but we're getting somewhere. So let's run this again and see what happens. So we must handle all possibilities of 205. That's true. So here, if we get Display event feels wrong. This is supposed to be handle. Oh yeah, display event. That is W display. So 1 is hard coded to handle display event. Else, we do this whatever the fuck we were doing before. Okay, area unit is ignored at 205. That's true. So I'll write try here for now. We return val at 87. So bytes 2 value is probably what I want. We want to copy it out, not get the pointer. And then expected type align 1 const u32 and found comp time in at 97. I guess this will just be allowed another any type. And hopefully the comp timeness will figure that out. Incompatible types, oh, it's actually more that len here also wanted bytes to value, not bytes as value. Bytes as value gets you like a pointer to the same stuff. But otherwise, the 2 value copies it out. So here we got object 1, code 1, invalid arguments for get registry. That's interesting. So this error code comes from this. And we had code 1. Invalid method. Method doesn't exist on the specify. No way, right? Crazy. Crazy, crazy, crazy. So I'm confused here because they were saying that I can use any ID, but I guess that is just not the case. I guess that is just not the case. So it looks like we have to use 2. We have to use 2, which is fine. That's fine. We are now starting to see like the beginnings of a correct handler loop, right? Beginning to. So what we have to do here is when we call get registry and we allocate an ID, we have to specify what this ID is, right? Like we have to write down somewhere. It feels like this is hard coded as well though, to be honest. Like given that this is failing on other IDs, it feels like we have to write 2 here. In which case we should probably specify somewhere that we have registry as 2. Then we can do object IDs registry here. And then here we don't need this ID allocator yet. Maybe we will come back to it. And then we can do registry handle registry event. And who knows what this is going to look like, you know, but we'll figure it out as we go. Okay. Okay. So our registry events, we're going to go back to the Wayland protocol, and we have events are just going to be global and global remove. Right? So we have anything in here that says WL display goes to WL registry. This is not delete ID. This is global remove. And then 0 has global, just global. Right? So if we run this again, we should see a bunch of saying unimplemented handler for WLRC global. That's super cool for us. Super cool. And now let's actually try to handle this thing. So let's do this. So display error, we have registry global. Okay. These names all are gonna have to improve, and they should probably all end up getting like namespaced in places too. But we'll figure that out as we go. So the name is an integer, not a string. Confusing. So we're kind of, I guess, gonna do the same thing here, where we kind of have like name interface and version. right? And we'll do the same thing where we have like an init function, which returns maybe failing registry global, who takes in data, and he is going to create a event data iterator, event data parser, right? And this is just going to go through those things in order, right? So name is equal to this, and we're gonna actually just, we can just return this thing kind of off rip like this. Boom, 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 boom. Dot name is equal to this. Interface is equal to get string. And version is equal to get U32. And you can actually start to see how an auto generator of this stuff would work, right? Like you could actually write a generic piece of code that iterates these things and calls the correct interface here. And then all you have to do is like auto generate these structs based off of these fields, right? Like you could have a function here. Should we write the fucking crazy function? Where it's like a function parse data response, who takes in a type as well as a data buffer, right? And he's just basically going to do this, right? So what we have to do is we have to iterate the fields of t. So stood meta fields of t, right? We can do something that's like var ret is a t that is undefined, right? This is going to return an error t. And then we can do something that's like switch field type. Is that how did this happen? This works. Field type, yep. So here we can be like, you know, if we see U32, we do one thing. If we're gonna say ret field name is equal to try it get U32. Where we need it to be defined, so it's gonna look something like this, right? And if we see a const U8, this is gonna be it get string. Right? This like might work. So we can try doing this on the error thing just to kind of make sure it works. So we'll say return parse data response display error data. And then here, can we change our get request for get registry to just like return like try with 4? Else prong required on switching on type. That's true. On implemented. Can I do like, can I add the type string in here? Can I do like compile error with, I guess it's just since it's compile time, we can do field name on implemented parser for this. Yeah, so this still works, right? Which is super fucking cool. Right? So I don't know if this is like reasonable. It might not be. But you can see now that like you can see that the generic version of this is starting to like seem possible. Right? Because now all you have to generate is like the data types of these structures, which is kind of fun. Okay, so here we should be able to try parse data response registry global as well with event data. Probably put this in squiggle brackets. And can we std debug print what we got? We probably want to do like name. How do you do this? You do name UD interface S version D. Okay. Global name, global interface, global version. Okay. We need to fix our request to object IDs display. And we should see a bunch of, oh, really? Sorry, it was registry. Oh, dude. That's actually so fucking cool. That's actually so sick. Okay. All right. So what now is next? I guess we have kind of successfully communicated with the Wayland server at this point. And now somehow we have to get a window from this thing. We have to get, so I would presume that it's from the Wayland compositor interface. A lot of these look like KDE extensions because we're using KWin, right? Some of these I've seen while I've been doing some reading. I've seen this DMA buff, ZWP. So I think that ZWP is probably something about like something extension, right? If you go to Wayland protocols here, this Wayland Explorer, they have stuff in here like Linux DMA buff, and Linux DMA buff is specified as ZWP. So I'm assuming that Z stands for like extension. Z for extension. Extension. Like this. There we go. That's a gamer tag if I've ever seen one, dude. Are you crazy? Throwing some random capital Z's in the middle of a word? That's total gamer tag shit. So we can probably assume that WL Compositor or WP Viewporter. WL Compositor feels right. Can we look for the WL Compositor interface and see if that gets us something? I know that I could continue reading that blog post, but I feel like exploring it ourselves might get us a more like a better feel for what's going on here. He's in charge of combining the contents of multiple services into one displayable output. So we can ask the compositor to create a new service. That sounds a lot like a window, right? Like, am I crazy? And then how do I make a window that has like how do I say this? Window decorations, right? If I remember correctly, a big part of this like step to Wayland was this concept of client-side decorations. And I actually don't know if my application in Firefox here, I don't know if KWin is drawing this thing or if I'm drawing this thing. It feels like KWin is, right? Because like Firefox is a GTK application, but this has like KWin stuff on it, right? So it really feels like the header bar is drawn, which feels like, is there like a Wayland protocol create window with decorations? I guess we will maybe we will cheat. I think client-side decorations are optional. Like for example, how Chrome puts tabs in the window bar. Right, so there must be some way to opt in, which is why I was looking at this and it doesn't feel right, because all this is create an ID with a new service. But we could also just try it, right? We could just try calling create service and see what happens. So I guess we will, unless there's another thing in here that looks equally likely. So given that this is the first thing that comes back, that also seems important, right? WL output seems interesting as well. But we'll see. What are these name fields for? That does not seem clear to me at all. Right? So when we get a global, with the given name is now available. So I guess is name the object ID? It doesn't seem that would explain the skip of 2 here, right? But we thought that number 1 was WL display, right? So to understand messages, the firstly, object ID is pre-allocated as the wayland display singleton, right? So this doesn't feel quite right to me unless WL compositor is a singleton global. This is a special singleton object. Like, it seems odd to me. There's no way that these can have the same ID, right? So we're missing a piece of information. You want this protocol's XG decoration unstable. This interface allows a compositor to announce support for server-side decorations. So then we are looking for decoration. I see. I see, I see. So this guy must be advertising. So we can ask him for top level decoration, a new decoration object associated with the given top level. Creating top level decoration from an XDG top level which has a buffer attached or committed is a client error. Okay. Oh, and then this allows us to toggle server-side window decorations for top-level surface. I see. So probably it does something by default, and we can ask it to turn it off. I see. I see. I see. I see. Cool. Okay, let's check. My guess is that we call compositor create surface. Let's see if that's what this guy did. Let's see if that's what this guy did. Can we just look for like create surface? Okay, that's a good sign. And so he calls this after at some point, right? So he calls this on his first iteration of the loop. Okay, sure. Let's create a wayland surface. What the fuck is an XDG surface? What the fuck is XDG? Oh, XDG is the desktop standard. The name is an ID associated with the interface, not an object ID. You call wayland registry bind. Okay, okay. That makes sense. So if we go into wayland registry, they have a bind thing, which takes in a name and a new ID. Ah, aha, aha, aha. Thank you, thank you, thank you. Okay. So I guess here we are kind of iterating objects, right? Here we print the objects we care about. And I'm thinking for a second. I guess what we want out of this is the interface ID. Right? We want some sort of like registry global. Oh, which we have here. So if we get an event from the registry, we are going to get some action. Yes. Right? And our actions could be global, which is going to have some parameters, name and an interface. Right? Okay, okay. Or global remove, which could be a name. Okay. So now we can kind of say that we have the same idea here. Now this is kind of, maybe here we will give these things named names. Something like this, I guess. And then here we will just kind of have the mappings here. So here we will have a registry action. And here we will return on 0, we return kind of like this. global is equal to this. And on 1, we return kind of like the same shit. So actually we kind of get rid of some brackets here, which is kind of nice for us. And this is going to be global remove is registry global remove. Yeah. Okay. Okay. Then when we get a registry event, we are presumably going to do something with it, right? We're going to be like, we have some action. And so this being called handle registry event should probably be more like a parse registry event, right? And then we are going to do something with that action. So if we have some sort of like global remove, we're going to say stood log warn, no registry to remove from. Right? We don't have any object registry right now, but eventually we will have to add one. But if we have a global, I guess we are going to have to unconditionally mark that that object ID is used. No, these are not object IDs. These are names. These are names. So really we can ignore the things we don't care about, but bind things that we do care about, right? So if we see, if we see a name of WL compositor, we are going to bind that thing. I think that makes sense. That makes sense. We're going to be like, yo, can we send an event by, we'll call this registry bind. We're gonna have to, we'll have to fix all of the naming schemes later. I think that I'm in like exploratory mode right now, so I'm just kind of like putting everything in the root namespace, and we'll have to come back and fix it. We'll have to come back and fix it. But this registry bind is going to take in the name and ID allocate. And this is going to start at 3. And I guess we should like fix me, check if this is above all predefined object IDs above. Okay. And I'm actually going to set this to 4 here, just to intentionally skip one to see if it's like, if it is an assumed, if it is like an assumption from the compositor that these IDs are contiguous, or if we have like the option to do whatever we want here, right? That's not really clear to me yet. It's not clear to me yet. So this is kind of like an intentional let me fail if it fails, you know? Now, probably somewhere we actually have to write down the compositor ID, right? And so here, I guess we actually say compositor object ID is equal to ID allocate, and then we bind it. Or we just ID allocate once up front. If we know that we're going to want one, we can kind of just like hard code this ID here before the loop even starts, right? Yeah, that seems reasonable. So no, because we kind of need to know if it bound, right? So maybe we do something like this. And then we do this, and then we do this. Boom. Okay, now we need to implement this like registry bind. So where is this like other function that we wrote? Get registry. So I guess more likely what is going to end up happening is, I guess get registry cannot return a registry object because the registry object yeah, because we don't know the registry ID until we allocate it or something. I guess we could return a registry object here, but for now we will do it this way. So we bind a name as well as an ID, Okay. And is there some sort of like commonality here? Maybe, maybe not. We'll see. So we are going to pass a name and an ID. And then we get object IDs registry. We think this is like a special constant one. The operation is going to be registry ops bind. And the size is going to be registry bind message. Okay. The name is going to be whatever we passed in, and the ID is whatever we passed in as well. And now we just need a registry ops thing. And based off of the protocol docs, it looks like what W registry has only one element called bind, so we're going to assume that this is ID 0 for now. Okay? This guy also needs the socket. Looking at libwayland server source, which most compositors use, it wants contiguous object IDs. Okay, I will maybe come back and look at that later. But for now, I am okay with just kind of doing this test first. But appreciate the lookup. Appreciate it for sure. So this comes from g.name, I guess. Okay. And like, is this? You could maybe like auto-generate this structure, but I mean, this feels fine to me. It feels like you do have to write this out for the most part. So I'm okay with this. I'm okay with this for now. All right. So I guess here we will do a std debug print sent bind compositor request, just to make sure that we are somewhere sane. Registry action implicit returns 236. Right, so in this, there's going to be this case where we did not find one. And so I guess for now, I will, instead of doing like an error null, I'll just say return error unknown event, because I don't want to deal with like the extra unwrapping that has to go with it. 278, we need to pass a U8 in here. And then const U8 found U32. Oh. Did I just fuck up? G.name. I thought this was U32. It is. Registry bind. U32. What's it complaining about? Oh, at 278, we are supposed to be comparing with interface. Oops. Iliante's quick, man. I don't know if I'm saying his name right, but when you're like, when you're catching my errors that quickly, it's like, damn, you're keeping up. You're keeping up. The book says something about the object IDs. Do you know which chapter? When a message comes in, new ID sends the object ID for it. The interface is established through additional arguments of grade 1 in advance. This object ID can be used in future messages, blah, blah, blah. IDs begin at the lower end of this bound and increment each new object allocation. Ah. I guess you are right. So presumably this will fail. But we do not notice because we are now in this case where we are not doing this all the time. So we actually probably want some sort of like while true here, where we want to read into our buffer. Now we should, for now, I'm just going to do something where we say std debug assert. We're going to assert that we get full messages right now because I don't want to handle partial messages right now. So we're just going to say it buff len is equal to 0. And hopefully that means that we can kind of do this. And hopefully we just get the next event back. But instead we got nothing. can we print out? I mean, we see here that we got 1 byte. So it looks like maybe binding the compositor does not emit any event. Right? So maybe we can just immediately fucking send out a create surface request right after. That seems possible. Seems possible. Can we try that? If we do a function, where is our senders? Over here somewhere? Function compositor create surface. And what does this thing take in? It just takes an ID. And this is gonna look similar, I guess. It's just gonna be a create surface message. I guess maybe we could just write message here so that we don't have to rename it every time, because these are kind of scoped. He's just gonna have an ID, and we are gonna assert that we are the size of message. I'm sure that there are some commonalities in this that could be factored out. I just do not care right now. I do not care. Okay. So let's do here, try compositor create surface on the socket given our compositor object ID now, which should be sane. Okay, so that also did not fail, but again, we're kind of giving like no indication that anything is happening. But I guess maybe a WL surface will now, maybe we do something with this, you know? An on-screen surface. Good evening, it's 1 a.m. Hell yeah. Dude, 1 a.m. Friday night, maybe drunk, watching Twitch streams of coding. Good fun. So, how does Wayland create a window? We don't know yet. We haven't figured it out. We're getting close though, I feel like. This WL surface feels close. So surface is a rectangular area that may be displayed on 0 or more outputs and shown any number of times at the compositor's discretion. They can present WL buffers, receive user input, and define a local coordinate system. That sounds a lot like a window. The size of the surface is described in the surface local coordinates, which may differ from buffer coordinates of the pixel content. In a case of a buffer transform or buffer scale is used. Okay, that's kind of interesting. A surface without a role is fairly useless. A compositor does not know where, when, or how to present it. The role is the purpose of the surface. Examples of roles are cursor for a pointer, a drag icon, a subsurface, and a window as defined by a shell protocol, e.g. WL shell get shell surface. Okay, so maybe we weren't supposed to make a service. Maybe we weren't supposed to make a service. Maybe we were supposed to call it this. A service can only have 1 role at a time. Initially, a WL service does not have a role. Once a WL service is given a role, it is set permanently for the whole lifetime of the service object. Giving the current role again is allowed unless explicitly forbidden by relevant interface spec. Okay, surface roles are given by requests in other interfaces, such as pointer set cursor. Okay. The request should explicitly mention that this request gives a role to a WL surface. Often this request also creates a new protocol object that represents the role and adds additionally functionality. Okay, when a client wants to destroy a surface, they must destroy the role object before the surface, otherwise the defend role. Okay, makes sense. So how are roles that are given by requests in other interfaces? So can we look at WL shell get shell surface? Is WL shell a extension or is that here? Get shell surface. So here we give him a surface object and then we assign a new ID for the shell surface. Okay. That seems reasonable. So once we've constructed our surface, we can ask him to create a shell surface. So this is get shell surface. And this takes an ID of the new surface ID, shell ID, we'll call it. And then we will pass in the surface ID. You're on the right track, but that WL shell thing is deprecated, replaced by XDG shell. There's a big red thing here. Use XDG shell. So if we just don't use XDG shell, I mean, it's like It's not. It won't not work. It won't not work. So maybe we start here and we'll just put like a fix me xdg shell because I don't really want to like I don't want to like get another specification if I don't have to right now. Okay. So this object ID, I guess we need the WL shell. Oh, I mean, we need one of WL shell or XDG shell. So if we're going to do this, we might as well do XDG shell. We might as well do XDG shell. So where was this? Let's go back here. XDG decoration, XDG shell. Here we go. Here we go. So how does this work? XDG top level sounds like probably what we want. Set window-like properties such as blah, blah, blah. XG top level. Well, okay, can we print out the, let's go back to printing out our options. We can go back to printing out our options. So where is that? This is on our display event, registry event. Yeah. So here we should just log, else we will say, stood log debug, unused interface, G interface here. Okay, so presumably one of these options is XDG shell, XDG WM base. Yeah. Okay. And then we have XDG positioner, XDG surface. So presumably the WM base, we need to create a surface here. Yes. Okay. Okay, so we are going to, this means that once we get the compositor, we need to wait until we also get the XDG WM base out of it. So first we'll do this. Right, shit. There, boom. Okay. And then we are going to have to do something like check if we have created the surface yet. So here we're gonna have like var xdg WM base object ID. Right? We're gonna have both of these things. And here it's gonna look very similar. We're going to registry bind. We're going to first get the XDG WM base object ID. We are going to bind this thing, but to this. Which sounds a lot like, by the way, that these could be automatically mapped up. And then down here, just kind of at the end of this loop, maybe we kind of do all this. We'll say like if surface bound, we kind of do all of this stuff. I guess we can create the compositor surface off rip. We'll do it here. Wait, no. Registry bind binds this thing with that ID. What does compositor create surface then? We don't have the... Oh yeah, that's fine. That is fine. So compositor create surface. I'm actually a little confused again. This thing takes in a new ID, which means that this guy, I didn't finish this. That's why. I didn't finish this at all. So the ID, this needs to have the surface ID as well as the compositor ID and the surface ID. There we go. So now this guy, we get that's probably why this shit was working before. That makes a lot of sense. We get this compositor ID and we want compositor ops now, create surface, which is 0. Oopsies, 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 oopsies. Compositor ops, and this is create surface. Okay, compositor ops, create surface. And this is going to be the surface ID. There we go. And then we'll try that here. So we'll have var surface bound is equal to false. And here we'll have surface bound is equal to true. And now this thing needs a new ID for the surface ID as well. Nice, 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 nice. So we get in the compositor ID first, then the surface ID after. And presumably we have to do the same thing here. We might be able to collect all of these things into one big nullable. We might have to, but we will see. We will see. Okay, let's start here and see if this all still works. Attempt to use null value. Oh, it's true. So we'll do const compositor is equal to compositor object ID or else break block. Then here we'll use compositor. Boom. Okay. So we still don't get any errors here, which is probably good. And then we will also, I guess we'll just do if surface ID is equal to null here. Probably. And then we don't need this surface bound check. Okay. And then we can do the same thing here. But we are trying to attach the shell. We are trying to attach this. We're trying to get this XGG surface. So we have a surface object here, and we're trying to make a new XGG surface. So we're trying to make a XGG surface ID is a U32. Okay. And down here now we say if XGG surface ID is null, we try to get the surface ID. So const s, I guess we'll call it here. And then we will get the XGG base object ID. No, XGG surface ID. Okay, and then we will have to do a similar thing where we call get XGG surface. So this is XGG WM base get XGG surface. Okay, it's all starting to kind of make sense a little bit, I think. So we're going to go from the XGG. So here we're going to need the ID of the surface as well as the WM base. So WM base ID, the surface ID, and the XGG surface ID. Okay. Now, the ID that we are sending to is WM base ID. Okay. we are sending this to xdg wm base ops get xdg surface. The fields are two IDs. They are the ID and the surface that we are binding to. So this is the xdg surface ID comes first, followed by the surface ID. So maybe we'll name it WL surface. Maybe. Okay. So then we have xdg surface ID comes from xdg surface ID. And WL to WL. Okay. And then we need to define this ID. So that's going to come from, something like xdg wm base ops. And we are trying to call get xdg surface, which is 0, 1, 2. Yup. And then down here now we can call whatever function we wrote there. It was called xdg wm this. Takes the socket wm base ID. So here we need the surface ID as well as the base ID, which is xdg wm base object ID. Nice. Taking the base ID. Then what was it? Base ID, surface ID, xdg surface ID. Nice. Nice, dude. So we still do not have a window. We also don't know if this is happening. So std debug print sent xdg surface rick. We don't really know if we did this right. But we can take a peek. Yeah, so it actually does not seem like we got here. Can we say sent WL surface rec as well here? So that doesn't seem like it's happening either. Which is kind of surprising. Kind of surprising. Std debug print surface ID is null. Okay, let's try that. So he does say surface ID is null, but he's not getting out of here, which means that the compositor object ID is still null at this point, but we set it here. So what's going on there? WL compositor. Unused interface WL compositor. Oh, maybe I spelled compositor wrong. Compositor. I mean, that's fucking the same thing. Oh, you know what I was saying earlier that I didn't know if the null terminator was included? Probably is. So when we call get string here, it looks like we throw a little -1 in here. Okay. So now if we call if we have got 0 bytes, then that means the other side has closed. So we're gonna say return error closed. Okay, and we'll kind of see now what happens here. So sent this, got that, got invalid arguments for WL registry bind. Nice. Okay. So now Now, let's go back to having our ID allocator allocate at the right address. Which we said was 3. Okay. Invalid arguments for W registry to bind. 0, 1, 2. We have object IDs 1, 2, so this should start at 3. And so can we start by not doing this part? Because we're trying to bisect who is failing here. You know? Who is failing? W will display error. Invalid arguments for W registry at 2.bind. Oh, okay, so the at 2 is probably telling us that it's object ID 2. And it looks like it's here, probably. Oh, I guess we don't know who is binding incorrectly. So we can not bind the XDGWM base here for a second. And we'll see. So he doesn't like that. We'll just double check here that if we do this as well, no more errors, I assume. Yep, okay. So then the question is what are we doing wrong here? On registry bind. So he is saying in his error return that we have invalid arguments to bind, which is actually really good for us because that means that we have correctly called W registry bind. So we're calling the method that we think we are. So that means this is right and this is right. Now he's probably mad at these, right? So the question is why? Why? Bind. So here we have a new ID and the unique name of the object. So can we look at what this guy does? When he calls bind, what ID does he use? Wayland registry bind, FD state name, so we aren't using the, oh yeah, we have the registry ID hard coded. So that's this is this. Then he has name, interface, len, and version. So I would assume that this stuff doesn't matter. That's probably logging information. He does write this stuff. So I'm confused here because his thing looks a lot like he's taking the registry here, opcode, yep, right? Then he writes the length, right? So that's what we're doing. But then he writes a string, name, string, version. That is not what this says. Right? That is not what this says is supposed to be done. So what the fuck is going on there? How is that possible? Well, it could be that the version here is not the right version, right? We're seeing version 1, where maybe, I think I saw a version 5 on here, right? I'm pretty sure I saw a version 5. So can we maybe kind of unconditionally log this? And we'll also put the version. Okay, so we are seeing WL compositor 5. So maybe we need to look at updates to the Wayland protocol. That's kind of fun. That's kind of fun. Protocol. Wayland. So WL registry, this still says version 1. So I'm curious about where the version 5 comes from. Can we look at like... Yeah, that's actually really confusing. Really confusing. WL registry version 5. That's the version of WL compositor, not registry. Yeah, that's a good point. That's a pretty good point, huh? Thank you. Good eye. And we are looking at version 6, but that's okay. We're looking at the wrong thing there. That's fine. We haven't even got there yet. So then the question is why the actual fuck? Unless I'm missing something, here he's sending message size, so he's writing, yeah, why the fuck is he sending all this stuff back? Right, that just doesn't make sense. It doesn't make sense according to what we have seen in the protocol specifications. Globals and the registry. Binding to globals. Upon creating a registry object, the server will emit a global event for each global available on the server. You can then bind the globals you require. Binding is the process of taking a known object and assigning it an ID. Once the client binds the registry like this, the server emits the global event several times, advertises which interfaces it supports. Each of these globals is assigned a unique name, blah, blah, blah. To bind to any of these interfaces, use the bind request, which works similar to the magical process by which we bound the WL registry. For example, consider this wire protocol exchange. The first message is identical to what we've already dissected. The second was an event from the server. Object 2, opcode 0, with arguments to, yeah, sure, okay. We can write our simple Wayland client one that prints all the globals. Okay, but, oh, registering globals? Is that what I wanted? Because here he's not actually doing any of the stuff. When you... WL registry, get registry. Then he has the listener. And he has a global. Yeah, okay. And then you see register here. Creates interfaces and glue code, blah, blah. First is to register the global with function to rig up a resource, blah, blah, blah. So here's creating resources, which I thought we didn't have to do here. Yeah, this doesn't sound like what I want. This is the interesting part. I mean, we can just do that. We can just do this, but it's like why? You know? Like why? Why? Who says this is what we should do? like what the fuck? Can we look at like lib wayland maybe? Is this going to be simple? Where can we look at this? Do we have this already cloned in our build root from our test from the other day? We do. Okay. So in here, we could maybe see the generated code. Presumably, there is... This is object output. Wayland client protocol. Wayland protocol.c. So does one of these have like WL registry? And we have bind here. Okay. Okay. So where is like source Wayland client, who takes in client core and client protocol? So this doesn't even know about the registry, right? So that's a good sign. It does seem like he's kind of propagating into this client protocol. Okay. Oh, here we go. So get registry, double registry, add listener. Here we go. There's a bind function here. And we do see, in fact, that he does send all of those things onwards, right? That does look like what's happening here. He's calling with WL registry bind, interface version. Well, there's a lot of stuff going on here. A lot of stuff going on. That doesn't make sense. Looks to me like the XML was wrong. You can see the method signature there in the generated code. It was oosun. Oosun. I don't know what that means. But this looks. Sorry, registry bind. So the question is like, how does this get generated then? And what does WL proxy marshal flags do? WL proxy marshal flags. Like, what is this function? This takes opcode interface inversion. For her request to be sent to the compositor, he takes a opcode interface version, flags that modify, and then extra arguments. Okay, so anything after flags are the things that get sent there. It looks like. Translate the request from the given opcode, blah, blah, blah. For new ID arguments, this function will allocate a WL proxy and send the ID to the server. Blah. Oh. The new WL proxy will be returned on success or null. Okay, sure. Okay, yep. So the flag, bind WL registry bind. So here, anything after flags is the arguments. Yeah, so here he is doing name, interface, name, and version. So USUN means U32 string, U32 ID. Oh, I see. So then the question is where is this function coming from? Right? Like someone is generating this with client header. Wayland, so this is calling generated headers in this build is running Wayland scanner on the client. Right? And where is he getting the input file for this? So here he has input to output here. Input is Wayland protocol XML. Okay. So he's taking the Wayland protocol XML and generating client header as an argument here. And Wayland protocol XML is Wayland protocol XML. Protocol Wayland, okay. So in here, can we look for bind? I don't understand. Right, so this XML is being fed directly into this thing and spitting this back out. So maybe we look at the source code, which no fucking way, dude. Crimson Dawn is saying scanner.c 1256 registry bind is a special case. Okay, so interface and all. This might be a different version. Okay. An arg has of type new ID, but interface is not provided as in WL registry bind. Jesus. What a fucking shitty spec. Am I crazy? Can we look at the I mean, it's very possible we just missed something obvious. But I don't understand how that is possible. I mean, it's just crazy, right? It's just crazy. So here they have ID is of type new ID, but on new ID, they just have like special handling for if the interface is not provided. Where does like version get handled as well? Dude. Okay. So does that mean other cases where they have new ID? Dude. Dude. So in other cases, new ID has an interface associated with it. As like, for example, get registry. So if we go back to here and we look for get registry, he has this signature here does not look any fucking different from this one. So okay, on get registry, was it wayland protocol wayland XML? Here we go, probably. So we're looking at get registry. Okay. So these do look different, right? We see this guy has new ID associated with this type, where this bind does not. And so probably this bind call is the only one that doesn't have that interface hooked in. And it's just like not fucking obvious at all that if your interface is null, you have to pass in that shit. I mean, okay, fine. Fine. I don't know. I don't know how the fuck I was supposed to know that. But it is what it is. That's crazy. Okay. Unfortunately, I would love to keep solving this. But unfortunately, I am like pretty short on time today, so I can't really go much longer. So I think this is unfortunately where we're gonna have to call it. It's 4:30, and I have to get out of the house soon. So, apologies for the unsuccessful end of stream. I would have loved to get a window up, but it is what it is. I hope that it was fun to watch anyways. I had fun writing this code, and we will continue on hopefully tomorrow. If you don't, if I'm not on tomorrow, it's because I am hungover. But maybe I will be successful in limiting myself to the point where I will be intelligent still tomorrow. It sucks because when like when I work like a normal job, right, and I go to work hungover, you just sit at your desk and you suck that day, right? And it's just like you just suck, and what are you gonna do? But like when you're in front of the camera, it's so much worse. It's like you suck, but your boss is standing there, just staring at you slowly type and make mistakes over and over and over again. So hopefully I'll be up for continuing on tomorrow. But if not, I will see you guys on Sunday. If you guys liked what you saw, we stream most days at around 12:30 Pacific time to 4 Pacific time. It is 4:30 Pacific time now. So if you're watching live, 4 hours ago to half an hour ago is when I aim for. 12:30 to 2 is we do happy hour, which is kind of like investigation, bug fixing, minor features, vibes. We just kind of like hang out. Today we were poking around looking at virgl implementation in QEMU and the Linux kernel. If you want to check that out, those are archived on member videos on YouTube or on Patreon. If you want to see archives of the 2 to 4 segment, we have all of those are on YouTube. marked under playlists. So right now we are working on demystifying the Linux graphics stack, but we have a lot of other cool stuff in here if you want to go check out the archives. QR code decoder, Google Maps replacement, regex kernel driver, operating system, neural network stuff. If you want to go check those out, those are there. This stuff will go up on GitHub eventually. I will probably make a new repo here, but I do not have it up and running yet. But there is a GitHub link in the Twitch description if you want to check that out. There's a Discord link there too if you want to get updates for when I am going live or just like chat about shit off stream. I think that is all the plugging we have to do. You guys know the deal. We have to do the streamer YouTuber thing. So like and subscribe and use your Twitch primes if you have them. Otherwise, I think we say goodbye to YouTube and Twitch. Let's find someone to raid.